All right, so go ahead and take out your sheet that we did not finish yesterday. We're going to finish that last question. So let's go to question 5. Okay. All right. Some binary compounds that form between fluorine and various nonmetals are listed in the table above. A student examines the data in the table and poses the following hypothesis. The number of fluorine atoms that will bind to a nonmetal is always equal to 8 minus the number of valence electrons in the nonmetal atom. A says, based on the student's hypothesis, what should be the formula of the compound that forms between chlorine and fluorine? So I've got one chlorine. Okay. And it says, all right, so the hypothesis says that the number of fluorine is going to be equal to 8 minus the number of valence electrons in the nonmetal atom. How many valence electrons does chlorine have? 7. What's 8 minus 7? 1. So how many fluorines am I going to have? 1. So that formula would be ClF. I don't know why this line is crooked. B. In an attempt to verify the hypothesis, the student researches the fluoride compounds of the other halogens and finds the formula ClF3. In the box below, draw a complete Lewis electron dot diagram for a molecule of ClF3. Okay. So, how many valence electrons does chlorine have? 7. How many does fluorine have? 7 times 3. 7 plus 21 is? Divided by 2 is? 14. I was about to divide it by 4. I don't know why. So, we put chlorine. 1, 2, so that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. C says 2 possible geometric shapes for the ClF3 molecule are trigonal planar and T-shaped. The student does some research and learns that the molecule has a dipole moment. Which of the 2 shapes is consistent with the fact that the ClF3 molecule has a dipole moment? Justify your answer in terms of bond polarity and molecular structure. Okay? Now, you don't know a lot about T-shaped, but you do know a lot about trigonal planar. Okay? Trigonal planar means the molecule would be what? Flat. And the bond angle between all 3 would be what? 120 degrees, which means all of the molecules would have to be spaced out evenly, which means all dipole moments would do what? Cancel. Okay? So I know that this molecule has to be T-shaped because the dipole moment does not cancel. And that is my explanation. So in this case, instead of explaining it in terms of T-shaped, just flip it around and explain it in terms of how I know it's not trigonal planar. Does that make sense? Because I know about trigonal planar. Okay? So you'd say trigonal planar molecules are symmetrical with all atoms evenly spaced. So all dipole moments would cancel. So you could go ahead and say the 2 lone pairs makes it T-shaped, and it still has a polar moment. I'm not going to write all of that. I'm just going to write that. And I promise my writing was bad there, but it's not that bad. For some reason, my board is making my letters slant and go crooked, and I don't know what to do about that. So, huh? But it's not off on spacing. It's just off on crooked lines. It'll still fix it. I'll recalibrate it after this question. In an attempt to resolve the existence of the ClF3 molecule with the hypothesis stated above, the student researches the compounds that form between halogens and fluorine and assembles the following list. Based on the concept of atomic structure and periodicity, propose a modification to the student's previous hypothesis to account for the compounds that form between halogens and fluorine. Okay? So they left this one blank, but we already know, we just said that it would form ClF, and the student researched and found that it would also form what? ClF3, right? That's what they put earlier. So looking at those, what hypothesis would you come up with? Because this is one of those questions where, honestly, if you came up with a decent hypothesis, they gave you a point. Okay? So what hypothesis would you come up with? Well, just look at it. Form one. All right, so first of all, let's look at chlorine, bromine, iodine. Notice that I'm doing what? Going down the periodic table, right? So as I go down the periodic table, what's happening to the number of fluorines that I can bind? It's going up, right? So as I go down the periodic table, I can form more bonds with fluorine. What do I notice about the number of those bonds? It increases by 2 each time, and it's always what kind of number? An odd number. There you go. There's your hypothesis.
So as you go down the periodic table, the number of fluorines increase by 2, and they're always on.
There you go. So really, all they wanted you to there was just look at that and come up with what you would say is a hypothesis. And you got to realize it's a hypothesis, so it doesn't have to be correct. So just make a prediction of what you think just by looking at that. Yeah, as long as it's logical based on the data there, they would have given you a point. So those questions should be exciting. It's like, oh, well, I got this. All right, now let's move to the second sheet. Yeah, the one I gave you today. And we're going to start on the multiple choice side. All right, this is going to be a little bit of a review of stoichiometry and a little bit of a review of thermo today is what we're going to shoot for. Tomorrow I think we're going to review probably kinetics and acid-base equilibrium. That's what I'm thinking tomorrow is going to be. And then, yeah, Thursday I won't be here. I'm going to let y'all chill that day. So, okay, let's go ahead and get started.
Wait, our definition of chill or your definition of chill? Ours.
Yours.
Okay.
All right.
We chose that. Why are you not coming this Thursday?
I have to go decorate for prom at the Civic Center. So, I'll be getting ready for prom Friday. All right, what number of moles of O2 is needed to produce 142 grams of P4O10 from phosphorus, and the molecular weight of P4O10 is 284. Okay?
Good.
Are you want to answer this? Is what you're looking at?
No. All right. So I don't know how much O2 I need, but I know I'm trying to make P4O10. Okay. So the first thing I need is a mole-to-mole ratio. Okay. Well, I've got 10 oxygens here. I've only got how many there? 2. So what do I need to put in front of this oxygen? A 5. Right. So my mole-to-mole ratio is 5 to 1. We agree with that? All right. Now, let's talk about the amount they gave us, and then we'll talk about the number of moles that it's going to take. So, they gave me 142 grams of P4O10. I always want to get grams to what? Moles. How am I going to get these grams to moles?
Use that word.
Multiply by 2?
Just divide that.
Divide. This is the molecular weight. To get from grams to moles, we divide by the molar mass. Okay? To get from moles to grams, we multiply by the molar mass.
So it would be
So what's 142 divided by 284? Remember, you can't use a calculator on the multiple choice, so you got to know that.
Wait, 142, I understand.
This would be 45.
0.5. Huh?
Is that right?
Did everybody see that? Because 142 is half of 284, so it's 0.5. So if it takes 0.5 moles, I'm trying to get 0.5 moles of P4O10, how many moles of oxygen is that going to take? It's a 1 to 5 ratio, so I've got to take this number and do what? Multiply it by 5. What's 0.5 times 5? 2.5, so the answer is D.
Wow.
They should use a calculator. Check it
It's okay. It's because it's better. It's fine. All right. This next one. They give me a 20 milliliter sample of 0.2 molar potassium carbonate. And they give me a 30 milliliter solution of 0.4 molar barium nitrate. Before I go any further, they just gave me 2 starting amounts, which means I'm going to be looking for a limiting reactant. Okay? So, clue number 1, make yourself a mental note if you need to make yourself a mental note. If I have 2 starting amounts, I've always got to find a limiting reactant. Okay? Barium carbonate is going to precipitate. Precipitate just means it formed a what?
Solid.
A solid. It forms a precipitate. It formed a solid. Okay? So that means it took it out of solution, right? It's no longer floating around. The concentration of barium ion Ba2 positive in solution after the reaction is. So I've got K2CO3. I have barium nitrate. And I know that I formed barium carbonate, but that doesn't matter. Really, I'm just looking at these 2 starting amounts. Okay? So, I know they asked me for concentration, which is going to be what? Molarity, right? Which is equal to moles over liters. They also, remember, let's go ahead and get our mole to mole ratio. What's my mole to mole ratio of this to this? 1 to 1. So now we'll need the number of moles here. They gave me volume and they gave me molarity. Can I find moles? What is the moles going to be equal to? Molarity times the liters. Good job. So, if I have 20 milliliters times 0.2 molar, what's 20 times 2? 40, and since I have 1 decimal place there, I have to put 1 decimal place there. So 20 times 0.2 would be 4, and we're going to call this millimoles because we did it by milliliters instead of liters, right? Then I have 30 milliliters of 0.4 molar. What's 30 times 4? 120. And since I have 1 decimal place there, I've got to put 1 decimal place there. So this is 12 millimoles. Okay. Who is my limiting reactant? K2CO3. So that means I'm going to use all of it. How much of the barium nitrate am I going to use then? I'm going to use 4. So how many am I going to have in excess? 8. So that's how many barium ions I'm going to have floating around, because the 4 millimoles is going to form what? The barium carbonate, right? So to get the concentration in excess, I do 8 millimoles divided by, what's the total milliliters of solution do I have here? 20 plus 50. So how can I figure out what 8 divided by 50 is without a calculator?
Yes.
What's a number that's easy to divide by?
2, 4.
Maybe 100?
Oh, you're talking about,
I thought you were talking about
Yeah.
dividing 50 by.
Oh, no, sorry. So 8 over 50 would be the same thing as 16 over 100. What's my concentration?
You know, you make these things look so easy.
Yeah, I have to agree.
I would never even thought about it.
And
Look, and she didn't even pass it.
how are we supposed to pass this?
I passed it. I got a 4 on the mock last year.
Yeah, honestly,
Oh,
I would never think about doing that. I'd
I didn't
be
get a
like,
5,
oh,
but-
dang, all right.
I just be like, well, this number looks 20.
Yeah, that's it.
Yes, ma'am?
Would you send Jeff Ballard to the office, please?
Yes, ma'am.
Thank you.
No problem.
So only time, space between 160 and 200, that's 40. Space between 240, that's 40. Space between 150 and 160, that's 10. It's a little closer to that's that probably would have been my reason.
Yeah.
Yeah, because I remember, what did I do the first time I did it? I got it down to 4 over 25. I did it backwards. So instead of making it bigger, 16 over 100, I made it 4 over 25. And I was like, well, 4 divided by 20 would be point, what? 0.2. It would be 0.2. And so then I was like, well, it's got to be less than that, so I'm going to go with B. That's what I did in my head. So it worked. But that way is a lot easier. Try to get it to where you can divide it by something by 10 or 100 if you get stuck on the test. Okay? All right. The alkenes are compounds of carbon and hydrogen with the general formula CnH2n. If 3.50 grams of any alkene is burned in excess oxygen, what number of moles of H2O is formed? So, let's pretend like we just have one carbon. So how many hydrogens would that give me? According to this formula. 2, right? The number of hydrogens is going to be double the number of carbons. So what would be the molar mass of this? Carbon's molar mass is about what? 12. And hydrogen's is about 1. So 12 plus 2 is 14. How do I get from grams to moles? Divide by the molar mass. Or you could do that, Zach. You could say in 1 mole is 14 grams. Is that what you're saying? Same thing. We're still dividing. So what's 3.5 divided by 14? Ooh, we can do this.
Well, you need to get it to something.
You don't actually have to get it to something this time.
Well, it would go into 14 because 12 and then 13. Am I going on the right track?
I like it. It does go into 14 4 times.
Well, you know what? It was
Yeah.
somewhere.
So 3.5 divided by 14.
Wait, hang on.
Point,
I got this.
I got this.
0.375.
Yeah. Oh, that's what I thought.
Yeah.
What's our exit?
All right. It's 0.250. How am I going to get that?
Don't know.
Okay. So 3.5 over 14. Okay. If I double 3.5, what do I get? 7. Right? How many times will 7 go into 14? Twice. So how many times will 3.5 go into 14? 4 times, right? So this would be the same thing as saying 1/4, which would be the same thing as saying 0.25.
I kept looking at the 2.5 and I was like, but that's not right.
Okay.
That's not-
0.5. Notice, how many hydrogens do I have here? 2. How many do I have here? 2. So the mole to mole ratio is what? 1 to 1. So however many moles of the alkene I have is the exact same number of moles of water I will have. So the answer is A.
my bad.
All right, I want y'all to try this one on your own. Without me, because I won't be there. On exam day.
There is.
We're taking an auditorium.
They're giving us. We don't have money.
I get 52.
I bet you're getting money. Not for me, but maybe from everybody else. Like you're gonna be giving 37 and like Southern biology.
So how much money do you get money
50%.
for everybody?
Dang, I wish we got 50%.
So it's just like pocket money?
Yeah, well, they'll put it in my
You still have to get taxes.
But Future got,
It sucks, because by the time they take out taxes,
how many did Future have qualified last year? Like 11?
Yeah.
Oh,
we
yeah.
got $100 first year.
He
He made a lot.
he made a lot of money. Future made that quite a bit.
Okay.
Elrod had more involved.
Still try to be our cousins. And when did that happen?
Our whole lives.
That's what. Yeah, how did this
Because I don't good friends. I was like, all science teachers are friends.
Y'all went to school together. Y'all go to school together?
So